let us discuss about stationary waves. They are even called standing waves also. So, what exactly is a stationary wave? And what are the conditions for obtaining nodes and antinodes in them? So, two different concepts we just have to deal with. First of all, what is a stationary wave? When two identical waves may be transverse or longitudinal, traveling in opposite directions, when they superpose on one another, a stationary wave will be formed. Whenever a stationary wave is being formed, we will be finding loop formation in that. The wave goes like this and one more wave like this. This is a node, this is called a node, this is called a node. This one is an antinode, this one is an antinode. In fact, what is the importance of these points? Whenever we consider stationary waves or standing waves, nodes and antinodes are going to be formed. Nodes are those points where the pressure is maximum and the displacement is minimum. Whereas antinodes, when we consider, the pressure is minimum and displacement is maximum. These concepts, of course, we consider in the case of a longitudinal wave. So, whenever we consider this type of a stationary wave, distance between two alternate nodes, that we call it as wavelength lambda. Distance between either two successive nodes or antinodes, that of course we call it as lambda by 2. Similarly, distance between a node and a successive antinode, that distance we call it as lambda by 4. So, these areas we just have to check. The distance between two alternate nodes or alternate antinodes, that is called lambda. Successive nodes or successive antinodes is lambda by 2, and node and successive antinode or vice versa, whatever it is, that will be lambda by 4. Now, the next concept here is, in the case of a stationary wave, energy cannot be transmitted. Total energy, whatever is there in the wave, is going to be confined between these two fixed boundaries. This wave cannot go beyond this point. This same wave cannot even go beyond this point also. So, the total energy is confined to these two fixed boundaries. That is the concept. But whenever we are finding stationary wave formation, there are two different ways we can consider the formation of it. One is, the reflection may take place at the free end. Whenever reflection takes place at the free end, there will be no phase difference between the incident wave and the reflected wave. That means one can understand like this: if crust is incident over there, it comes back like crust itself, only direction that changes. The second one is reflection at a rigid support. In this particular case, the incident wave and reflected wave, they do differ in phase by pi radian. That means when crust is incident over there, that becomes a trough and comes back. That is the concept what we have to consider. So, at the free end or a rigid end, whenever waves are being produced, rather stationary waves are being formed, then what will be the condition for obtaining a node? What would be the condition for obtaining an antinode? Let us take up few equations for that. The very first concept is, let me take here, there is a wave of displacement y1, which is a sin omega t minus kx. That is one wave I am considering. This is of course along positive x direction. One can understand when we are writing this phi as negative, it is along positive x direction. The second wave I am considering it like this, that is the reflected wave, it is minus a sin omega t minus kx. This of course we are talking about at the free end. At the free end, right, the reflection is taking place now. Therefore, there will not be any phase difference. Only thing is, this negative phase earlier now becomes positive. That means it moves now along negative x direction. So this is the concept what we are talking about at the free end. This is the wave which is incident over there, and this is the wave equation which is actually of the reflected wave therefrom. Now when both together are just overlapping on one another to produce a stationary wave, what would be the displacement of the resultant wave thereby formed? According to the superposition principle of waves, we now can write y is equal to y1 plus y2. So resultant displacement of the resultant wave, that is the algebraic sum of their individual displacements, like we can say vectorial sum of their displacements, that is the point. So how to rewrite this equation? Now A, if you take a common, sin omega t minus kx, right, plus sin omega t plus kx. Now if we just expand this one, like sin c plus sin d, 2a will be getting sin of c plus d by 2, that we can write it as sin omega t, and of course we will be getting here cos kx. Rewriting the same equation, we will be getting 2a cos 2 pi by lambda into x into sin 2 pi by capital T into small t. Every one of us can understand straight away omega is angular frequency, which can be written 2 pi by capital T. K of course we can write it as 2 pi by lambda. So wave constant it is. Directly we can rewrite it like this, and this total term now represents the amplitude of the resultant wave thereby formed. So what we can understand from this one is, this implies amplitude of the resultant wave. When I consider it as A, that now becomes 2a cos 2 pi by lambda into x. But we can understand now this amplitude when it becomes maximum, the point which is called antinode can be expected there. When amplitude becomes minimum there, we directly find a node formation there. So that is a basic concept. So one can understand here, for the formation of antinode, for the formation of antinode, what should be the condition? This cos of 2 pi by lambda into x, that must be either plus 1 or minus 1. That is what is called the maximum value of that cos function. Whether it is plus 1 or minus 1, we will be finding the total amplitude becoming 2a. Whether plus 2a or minus 2a, hardly that matters, maximum amplitude we will be finding. So if you take this concept like, that can be rewritten as 2 pi by lambda into x, that now must be equal to n times pi. This n is an integer, it is a direct multiplication factor there, where we now can write n must be 0 or 1 or 2 or 3 and so on and so forth. Directly we can understand whenever we take cos 0, that is plus 1. Cos pi becomes minus 1. Cos 2 pi becomes plus 1. like that alternate plus 1 and minus 1 we can get for these values of n when we substitute in this equation. Then what is it we can observe from this? Pi getting cancelled. We now can write x is equal to n lambda by 2. What is this x over here called? It is the path difference. Path difference must be n lambda by 2. That is the concept. That of course we can write this way, x must be either 0. If I substitute n as 0 here, I will get 0. Otherwise, I will be getting, if I write n as 1, it will be lambda by 2. Next one 2 lambda by 2. Next one 3 lambda by 2. And so on and so forth like that. So, what is it you are going to get over here now? When path difference either is equal to 0, r lambda by 2, 2 lambda by 2, 3 lambda by 2 and so on and so forth, we will be getting directly the formation of an antinode there. Antinode of course is going to be formed at these distances means, can't you just understand from this? This implies distance between two successive antinodes. How much will this be? Take either the difference between first and second and third, or third and fourth, any two successive numbers you take. Is it not directly lambda by 2 please? So, lambda by 2 minus 0, 2 lambda by 2 minus lambda by 2, 3 lambda by 2 minus 2 lambda by 2, whatever you write about, it will be lambda by 2. That is the concept what one has to understand. So, whenever you are finding here the distance between two successive antinodes, that now becomes lambda by 2. That is the condition for obtaining an antinode there. So, what should be the ultimate condition one has to remember? That the path difference must be n lambda by 2. That is the case. Now, what would be the condition for the formation of a node? For the formation of a node, what should be the condition for that? One can understand directly cos of 2 pi by lambda into x, that must be 0. So, simply speaking, when this cos value becomes 0, total amplitude or resultant amplitude of the resultant wave formed over there, or the stationary wave formed, that will be 0. That is what is the condition for a node there. So, what we can understand from this one? This implies 2 pi by lambda into x, that now should become 2n plus 1 into pi by 2. In fact, every one of us can understand cos 90 is 0. After that, after every 180 degrees addition to that, you will be getting the value 0 only. So, what we can understand from this? Pi getting cancelled, this implies x must be equal to 2n plus 1 into lambda by 4. What are the values of n again? Once again one can say n must be 0, 1, 2, 3, 4 and so on. So, what would be the value here? Therefore, you can understand x must be either lambda by 4 or 3 lambda by 4 or 5 lambda by 4 and so on and so forth. Directly we can take these are the values for path difference for obtaining a node formation there. So, what one should understand here, the condition for the formation of a node is this, condition for the formation of an antinode is this. So, one can understand even here also what would be the distance between two successive nodes. That distance again is going to be lambda by 2. Check this one, 3 lambda by 4 minus lambda by 4. It is lambda by 2. 5 lambda by 4 minus 3 lambda by 4. It is once again lambda by 2, and so on and so forth. Any two successive node formation displacements or distances, if you take and take the difference of those two or successive numbers there, you will be getting lambda by 2. That already we have seen in the concept of a stationary wave. Whenever stationary wave is being formed, distance between two successive nodes or successive antinodes, that always will be lambda by 2. Not only that, one can understand here according to this explanation, at every free end, we always used to find an antinode formation. One of the better examples for this, you are all aware of open pipe and closed pipe. When we consider open pipe, since it is open at both the ends, every time in every harmonic, we will be finding antinode formation. Whereas in the case of a closed pipe, when we consider, one end is closed for that. At closed end, we will be finding node formation, and at the open end, we will again be finding an antinode formation. So, at every free end, we will be finding antinode formation. At every fixed end, we will be finding node formation. That is the concept one should understand from this entire description. So, these two are the conditions for obtaining antinode and node respectively in the case of the formation of a stationary wave whenever the reflection that is taking place at the free end. Suppose if it is taking place at the fixed end, a rigid end is taken up. Now, the wave is reflecting there from the rigid end, and we are getting stationary wave formation in that by any chance. Then what would be the variation you are going to observe in this case? Very simple. If you take y1 as a sin omega t minus kx as the initial or incident wave, for the reflected wave, you should write a sin omega t plus kx with a negative sign before. What for that negative sign we can understand? I have already told you, whenever there is a rigid end, when reflection is taking place, there will definitely be a phase difference of pi radian between the incident wave and the reflected wave. Thereby, you will be getting a negative sign over here. Once again, the same methodology. There is absolutely no change in the method what we have adopted. Same methodology is to be repeated. That time, what would be the equation of the stationary wave? You will be finding this equation varying slightly. 2a cos 2 pi by lambda into x sin 2 pi by t into t you have got when the reflection is taking place at the free end. Suppose if it is taking place at the rigid end, then what happens? This becomes 2a sin 2 pi by lambda into x, and this becomes cos 2 pi by capital T into t. That everything with a negative sign. So, this is the only variation what you are going to observe. That means what one has to understand, whenever we have to get the stationary wave equation. What is the basic equation of a stationary wave, please? 2a sin omega t cos kx or 2a cos omega t sin kx. That of course, depending on the direction of that one and all, we can put a negative sign before. That is a different issue that directly you can understand also while writing or while considering where the reflection that is taking place and how it is being reflected. So, this is what is called stationary wave equation. Y is equal to 2a sin omega t cos kx or 2a cos omega t sin kx as such. So, these are the concepts one should remember as far as stationary wave or standing wave that formation that is concerned.